Yes, Gayatri, unmute.
Hello.
Yeah, start.
या कुन्देन्दु तुषारहारधवला या शुभ्रवस्त्रावृता या वीणावरदण्डमण्डितकला या श्वेतपद्मासना या ब्रह्माच्युतशङ्कर प्रभृतिभिः देवैः सदा वन्दिता सा मां पातु सरस्वती भगवती निःशेषजाड्यापः निःशेषजाड्यापः निःशेषजाड्यापः. Thank you.
Thank you, Gayatri. So, the aim of AICTE ATAL Academy is to empower faculty to achieve goals for higher education such as access, equity, and quality. Its plan is to help in imparting quality education in technical education in the country and to support technical institutions in fostering research, innovation, and entrepreneurship through training in various emerging areas. The Atal Academy is to be included in the Guinness Book World of Records for its excellent number of FDPs. It has recognized the FDPs as world record under 1,000 online FDPs in over 100 emerging areas. Will benefit 1 lakh faculty members across premier institutions. We welcome today's chief guest, Dr. Mukesh D. Patil Sir, Principal, Ramrao Adik Institute of Technology, Navi Mumbai. Welcome to you, sir. Engineers today have propelled the world to a new era of technological advancements. Blending curiosity with scientific temperament is the need of our as world faces a new set of challenges. Nurturing this spirit for 37 years stands Ramrao Adik Institute of Technology, RAIT. The institute is one of the oldest and finest colleges of Navi Mumbai, located in lush green Dr. D.Y. Patil Technical Campus. RAIT provides state-of-art amenities which combined with experienced teachers and an amicable environment ensure an all-around development of students. Its proximity to Mumbai-Pune Express Highway makes it easily accessible. The institution also organizes various student-centric activities which provide students with obtain number of learning opportunities. The syllabus of RAIT is integrated with Harvard Business School online certification courses. Department of Electronics Engineering offers BTech in Electronics Engineering, BTech in Electronics Engineering with specialization in embedded systems, BTech in Electronics Engineering with specialization in VLSI design. It is said by Marvin Minsky that will robot inherit the earth? Yes, they will be our children. The influence of robotic technologies on society and human being has been very strong. The application of robotics range from space exploration to underwater exploration to personal assistant. The FDP aims to make the participants aware of interdisciplinary nature of the field of robotics, emerging research trends and advancements in robotics. The FDP will involve lectures by experts from IITs and R&D institutions, demo hands-on sessions. On behalf of Electronics Department, I, Sushma Kodagli, welcome you all participants for FDP on robotics. Now I request Coordinator of FDP, HOD of Electronics Department, Dr. Vishwesh Vare to say few words. Over to you, sir.
Thank you, Sushma Madam. Welcome all participants, Honorable Principal Sir, Dr. M.D. Patil, all the HODs and all my colleagues and dear participants. It gives me immense pleasure to welcome you all for this 5 days AICTE sponsored ATAL FDP on robotics with the emphasis on emerging research trends. As said by Sushma Madam, we cannot deny the ubiquity of robots. We cannot deny the omnipresence of robots in our day-to-day life. They have just started coming in. If you talk about industries, then robotic manipulators are used, automation is used everywhere. And now robots have started also showing their importance and their necessity in various fields like medical science. I mean, we just are going through a very difficult time of COVID-19 pandemic, and we all have read these news that robotic nurses and robotic assistants are helping COVID-19 patients to deliver the medicine, to deliver the food and everything. So this is the need of the country and the world and the technical field that robots take the place and they help mankind and human beings in all the endeavors. Of course, when the situation is very hazardous, when the situation is very difficult, where a human being cannot enter, it is the robots who are doing our job and keeping all of us safe. This is as far as the layman is concerned. But this FDP, which has commenced today, from today, it will give a serious thought and serious discussion about the emerging research trends which are available in the field of robotics. So when we started or when we decided to float this FDP, we had a focus in our mind that there will be a lot of FDPs on robotics which will talk about applications. Let us talk about the research potential and research possibilities that are available in the field of robotics. Okay, so with this aim and with this target, we have decided to focus on the eminent, we have invited eminent researchers and they will be focusing on the what are the current research trends which are available in the robotics and where we as a faculty members or as researchers or as academicians or even as industry people, where we can contribute and where we can do our own. So with this motivation, I request all the participants to take active participation in this FDP and try to get maximum from this FDP. We have very variety of ranging topics starting from the multi-agent systems, autonomous robots, to robotic vision, to mathematical modeling of robotics. So all these areas we will try to cover, and we have chosen our experts or handpicked our experts in a way that all the participants get a panoramic view of what are the various research dimensions available in the field of robotics. And I am sure that all the participants will be very much benefited, and it will be a big opportunity for and a unique opportunity for all the participants to get an idea of what are the thrust research areas available in the field of robotics. So I welcome all the participants, and I hope that these next 5 days we will have brainstorming sessions, and we will try to get all the necessary information in the field of robotics with a clear-cut inclination towards the research in the field of robotics. Now let me give you some idea about the statistics of the robotics of this FDP. When we floated this FDP on the ATAL portal, immediately we started receiving overwhelming response from all the participants. We received around 252 applications, out of which, as per the limitations of the ATAL FDP portal and ATAL Academy, we have to sanction only 200. So we have finalized 197 participants for this FDP, and out of these 197 participants, around 70 participants, 70-80 participants are from the state of Maharashtra, and other all faculty, all participants are from all over India, starting from Jammu Kashmir to Kanyakumari and starting from Assam to Gujarat. So we have almost representation of all states as participants in our FDP, and we have also got a variety of cadre in our participants. We have participants both from academia as well as from industry. Also, there are PG students, research scholars who have we have enrolled for and we have registered for our FDP. So with this, I welcome you all, and I hope that you all will be greatly benefited and there will be very good takeaways from this FDP. Of course, the instructions from time to time will be given by my colleagues, but if you have gone through the ATAL Academy portal, that 80% attendance is mandatory, and you have all to clear the online quiz that will be conducted on the last day, that is on the 18th of this month, 18 December, Friday. Schedule has been shared with all, and I hope you will all attend all the sessions, and attendance is being taken automatically as we have yesterday floated it. It has been taken automatically using this Microsoft Teams. Okay. So with this, I welcome you all and wish you all a very active and very involving 5 days FDP on this robotics with research, with focus on emerging research trends. Now, I also take this opportunity to introduce our honorable principal, Dr. M.D. Patil sir. Dr. Mukesh Patil received his MTech and PhD both from Systems and Control Department, Indian Institute of Technology, Bombay. He is an avid researcher and a well-known academician. He has to his credit many papers which are published in international and national journals and conferences. He has also contributed in filing very good patents in the areas of fractional order control and fractional order modeling, and he is a very senior faculty in the field of instrumentation engineering in University of Mumbai and Central India, and he has withheld all the important responsibilities, academic responsibilities. He is also BOS member of University of Mumbai for the instrumentation engineering, and he is also serving on BOS as a BOS member for various autonomous institutes. And under his able leadership and guidance, RAIT, Ramravadik Institute of Technology, and our Department of Electronics Engineering is forging ahead, is moving ahead, and we are achieving milestones one after the other. I now request our honorable principal, Dr. M.D. Patil sir, to please enlighten us with his views and with his speech. Over to you, Patil sir.
Thank you, Dr. Vishwesh. First of all, I welcome all the participants for this FDP on robotics, which is approved by ATAL Academy of AICTE. And I would like to congratulate Department of Electronics Engineering for taking the initiative and applying for this ATAL Academy for this FDP on robotics, which is an emerging area. And as discussed by Sushma ma'am and Dr. Vishwesh, robotics, as everyone knows, as applications of robotics. So I will not speak much more on robotics because uh, they have already introduced the different applications and domains of robotics. Uh, I just want to highlight as discussed by Shushma ma'am as ATAL Academy. This is recorded in Greenwich World Record as training 1 lakh faculty members across the country by conducting 1,000 of FDPs in 100 emerging area. And this is a very nice initiative taken by AICTE. So on this platform, I would like to thank AICTE for approving this FDP for our institute. Our institute always believe in hands-on training and training for the faculty members and students, and we regularly conduct such type of FDPs and training programs for the faculty members and students. This is the third FDP which is approved by ATAL Academy for this institute, and every year we arrange more than 20 training programs for the faculty members on various domains, and uh, this has been possible only because of the motivation by our chancellor and president of this institute, Dr. Vijay Patil sir, and the first lady Shivani Patil ma'am, who are the constant source of inspiration. And since this institute is existing from last 37 years, we are excellent in teaching, as well as now we are moving ahead with excellence in research. And our students are motivated to take part in various competitions. We are continuously winner in the in SIH, which is organized by MHRD. Uh, so we are winning a prize either in software category or hardware category, and this is what is the outcome of the efforts taken by our faculty members for the skill development of students. And this is what is also mentioned in new education policy, as government wants a skill-based education, not the traditional one which used to happen in previous years, where only the classroom teaching was insisted. But if you want to compete for the world, then we need to have our students which are developed, which have a skill which can be used to compete the students across the world. So skill development of students is an important factor, and which we have initiated long back, and which for which is the outcome as our students are getting placed in various industry, and students are winning the prizes in the competitions like Smart India Hackathon, which is a prestigious competition organized by MHRD. Uh, and this is happening across the departments where the students are uh, actively taking part in the various activity, and uh, we provide all the platforms, whatever the hardware and software are required for the students for developing the skills of the students. Everything is available, and I must appreciate my faculty members also who are taking equal efforts to train the students. So this is a platform where faculty members must attend such kind of FDPs, where the faculty members will be skilled, will be trained on the various trends and the emerging areas. And once faculty are trained, I am sure that they will disseminate the knowledge to the students, and whatever the aim is of the government is there to have the uh, skill development of the students in coming years, which will be the outcome of national education policy. So I will urge all the faculty members to actively take part in this FDP, and please, whatever the knowledge you get, share this knowledge to the student, disseminate the knowledge to the students, so that the students will be trained and the students' skill sets will be improved. And whatever the purpose of AICTE is there, as to develop the skill sets of students and faculty, it will be fulfilled. So I'm sure that all the speakers in this FDP are eminent academicians from IIT and researchers from various research institutes. Their expertise will help you to understand the concepts of robotics. There might be some participants who will be a beginner in this domain, some might be expert. Okay, but when we are conducting FDP, as we always any FDP will always start from the basic to the advanced topics. So the experts will take care of all these aspects, and during hands-on, our faculty members and will show you the demonstrations of various robotic application. So I'm sure that this FDP will be fruitful to all of you, and this will give you the beginners will get a kickstart to work in this domain, because this is the one of the emerging area uh, which will have n number of applications in the years to come. People are using robots nowadays also, but with a lot of limitations, I will say. Okay, but there will be a lot of scope in this application, and in years to come, you will be able to see the robot at each and every point in each and every application. So I wish you all the best, and again I would like to congratulate Department of Electronics Engineering for taking the initiative, and I'm sure that this FDP will be fruitful for all the participants. Thank you.
Thank you, Patil sir, for your always encouraging and enlightening speech. Now I present vote of thanks in front of you all. It's my privilege to present vote of thanks today. We are thankful to AICTE ATAL Academy for giving us an opportunity to conduct FDP on robotics. We are really thankful to our beloved Dada, Padma Shri, founder Dr. D.Y. Patil sir, President Dr. Vijay D. Patil sir, Managing Trustee Shivani Patil ma'am, for always encouraging to conduct such sessions. We are grateful to our Vice Chancellor of Dr. D.Y. Patil University, Dr. Shirish Patil sir, for his timely valuable guidance. We are thankful to our Registrar, Dr. Tanmay Sinnarkar sir, and Principal RAIT, Dr. Mukesh D. Patil sir, for motivating us and being supportive for academic matters. We are thankful to FDP team and faculty members who are directly or indirectly involved in the conduction of this event. I am also thankful to all the past participants who have joined this FDP and hope you will get benefited of the FDP. Thank you all.
Sushma madam, please give the instructions to all participants.
Yes, sir. Yes, sir. So again, I'm repeating the general instructions which are already shared with you. The first is that Microsoft Teams is going to be used for online conduction of this FDP. All the approved participants will receive the invitations for all the sessions. There is no software installation requirement for participation. Microsoft Teams has a web-based client. Participants can join the sessions using the web-based clients. Also, all the sessions will be streamed live on YouTube at the following URL, which is already been shared to you. Please go into the WhatsApp group and you can view it, right? During question and answer sessions, if you want to ask any questions, participants can raise their hand and a moderator will unmute the participants. The attendance is recorded in Microsoft Teams software automatically with the sessions joining and leaving time. So we'll get an Excel sheet which will have joining and leaving time. Please remember 80% attendance and 60% score in the final exam is required for the certificate. Please fill the feedback form on the ATAL portal after the course. So please remember, for the certification, all these are mandatory: 80% attendance, 60% score, and you have to go to the ATAL website, ATAL portal, and fill the feedback form. The certificate is directly sent by AICTE ATAL portal after participants fill this feedback form, right? So these are the instructions which please participants have to record. Vishwesh sir?
Yeah, now our next speaker, Mr. Lentin Joseph, has joined. I welcome
Okay.
Mr. Lentin Joseph. Sir, welcome to deliver the talk in this FDP.
Thank you. Thank you.
Yeah. We can start, sir, as and when you are ready.
Sure. Maybe I can share the screen first. Just a
Yeah,
second.
yeah.
Sir. So,
Sir,
Yeah,
just we would like to introduce you first. I
sir,
request Sushma Madam to introduce Lentin, sir, and then you can start, sir.
okay, sir, fine. So today we have with us Lentin Joseph sir for the session. I welcome you, sir. Lentin Joseph is an author, roboticist, and robotic entrepreneur from India. He is founder and CEO of robotic software company called Cubotics Labs in Kochi, Kerala. He has 10 years of experience in robotics domain, primarily in robot operating system, OpenCV and PCL. He has authored 8 books in ROS, namely Learning Robotics using Python first and second edition, Mastering ROS for Robotics of Programming first and second edition, ROS Robotics Projects first and second edition, ROS Learning Path and Robot Operating System for Absolute Beginners. He has pursued his master's in robotics and automation from India and also worked as Robotics Institute, CMU, USA. He is also a TEDx speaker. Sir, I request you to start the session, sir.
Sure. Thanks for the introduction. And can you able to see the screen?
Yes, sir.
Sure. Okay. Just a second. Okay, guys. So good morning, everyone. So thanks for inviting me for this talk regarding robot operating system. So today, what we are going to do is we are going to see an introduction to a robotic software framework called Robot Operating System. Okay, so this is just an introductory class. We are not discussing more details about this framework. I will be discussing how what is robot operating system and how can we start with this framework. Okay, and what is its relevance? What are the things that we get if you learn this framework? Okay, so just take it as an introductory session, and as ma'am mentioned, if you have any doubts, I think you can raise the hand in Microsoft Teams, and let me open the chat box also. So if you have any questions, you can just type it in the chat box. Okay. So just raise your hand, and you can unmute your microphone if you have any question to ask, or you can type it. Okay. Anything will be fine. So I'm opening Microsoft Teams in one screen, and I am also taking the presentation in one screen. Okay. So I can see your questions that you are posting in the Teams. Okay. Okay, so I think that will be fine, and let's start. So, so ma'am already gave an introduction about me, and so basically, I'm a roboticist, like a person who love to work with robotics and also working in robotics. So I'm working in robotics from 2010, and in the meantime, I used to write books in robotics. Then I also have a small company called Cubotics Labs. It's a software development company for robotics application, and I'm also maintaining a blog called Robo Academy. So basically I'm like providing courses, then some free education materials, so those kind of stuff. And regarding my experience, working experience, I have worked with some robotic startup as first. Then I had done my master's in robotics and automation. Also, I worked in CMU Robotics Institute for a while. Okay, so these are my experience, and my main experience comes in this framework. It's called ROS. So we will be discussing an introduction of this framework today. Okay. Okay. So before starting, maybe I can introduce my books first. So like these are some of the books I have written regarding ROS. So there are 8 books. So I just put that books here. So like there are robot operating system for absolute beginners that is designed for, I mean, who are starting with ROS. Then there is mastering version. So and Rose Robotics project. So I used to work. I mean, I used to create free education materials for ROS, and also I used to write books. So these are some of the books, and these are some of the book I reviewed, again related to ROS, image processing, then robotics, those kind of stuff. Okay, yes. So before starting, I just want to ask you, how many of you heard about or how many of you work with ROS framework? You can just use the raise hand option if any, if you heard about or if you work with. Okay, I think I'm seeing a few hands here. Only one. Okay. Yes. Yes. Okay. Anyway, like we will see an intro about it. So don't worry. So here is the agenda of this presentation. So we are not directly starting with ROS. Okay, I'm assuming that most of you are beginners in this domain. So I will be starting with a small introduction to robot and robot programming. Then we will see different approaches for programming a robot. These 2 topics are very simple. Okay, then we will start with ROS. Okay, so we will start with ROS with an example. Then we will see various concept of ROS. Okay, and so in the meantime, like when I discuss this concept, if you have doubts, then just post it in the chat. Okay, because this is actually a pretty new concept to you, because and this is also about a software framework. Okay, so if you don't have any good background in the software, you can ask doubts. Even doesn't mind if it is a stupid question, doesn't mind. Okay, I can understand the situation. Okay, so you can ask any questions. Okay, so let's start. So as I mentioned, we can start with robot and robot programming, then robot programming approaches and rows. And also I would like to show you some interesting demos. Okay, so I have set up a virtual machine here. So I will explain that. Okay, so I have set up some demos for you. So I mean some of the application that we can do using ROS. Okay, so I will show you that also. Okay, so just start. So so I am assuming that you have heard about robot, and this block diagram you may be familiar with, but I'm just want to, I mean, explain this again just for introduction. If you don't heard about this, I can just explain it again. So what is a robot, guys? What is a robot? It's simply having these much of blocks. Okay, so if you take any robot, what you can see is these 3 blocks. Okay, so the first block is sense, then think and act. Okay, it's very simple. Like our human body, we have a list of sensors, right? In our body, we have eyes, ears, uh, nose. So these are our sensory organs, right? So similar to that, in robots, they have sensors. Okay, so the camera is a sensor, then a touch sensor is the ultrasonic sensor. So these are belong to the sensors. Then, of course, the think section is in human body is the brain, right? So in the robot, it's a computer. Okay, so a computer can be a full-fledged PC, or it can be a microcontroller. I think you maybe heard about microcontrollers, right? So it can be a microcontroller, and there is an ACT session. ACT means actuators. That means the decision, the control signals coming from the thing section is executing in the actuators. Okay, so what is the input to the thing section? It's a sensory organs. That is the sensory organs in human body. In robots, it's a sensors. Okay, like camera. And computer is taking the sensors value and processing it and taking a decision based on the sensory outputs. Then it is giving a control command to the actuators. Okay, so the actuator will move. So a robot will move, or it will, I mean, show some actions. Okay, so this is actually happening in a robot, right? So basic definition. So again, a loop, like what is happening in the physical robot, there are sensors. It is taking the sensor, the computer is taking the sensor values, processing it, sending the control signals to the robot, and robot is having the actuators, so it will move. Okay, so this is a loop. And this is one simple example. So I'm just demonstrating the sense, think, act loop using an obstacle avoidance robot. Okay, so in case of obstacle avoidance robot, the sense part is actually sensing the obstacles. Okay, it is having an ultrasonic sensors, some kind of distance sensors. Okay, so the sensor sense, like there is a wall, there is a wall 5 centimeters away from me, or like it is getting like there is an obstacle, there is 5 centimeters away from me. Okay, so that signal is sending to the think section, and think is like taking a decision. Oh, it is too close, so should I move away or not? Okay, so it will take a decision like it should move away. So that decision is sending to the actuators, and actuators like move the motors actually away from the obstacle. Okay, and this loop is continuously going on. Okay, this is actually happening in any robots. If you take any, so this is the case of obstacle avoidance robot, but if you take any robot, this is what actually happening. Okay, and this is an expanded view of robot. Like I just want to just demonstrate what are the things inside. So in the actuators, there are different kind of actuators available, like servo motors, stepper motors, um, and uh, what are the things like industrial servo. Yeah, so there are a list of servos, stepper, then DC gear motors are available. So that is belonging to the actuator, actuator part. Then we have the sensor part. So sensor part, we have a list of sensors like ultrasonic sensors, camera, LiDAR. So those are belongs to the sensors. Then there is the think part. So this is what our focus is. Okay, because our objective is to program robots. Okay, so mainly the program is actually putting in the think part. Okay, so in think part, in the think section, you can use a computer. Okay, a fully fledged computer we can install an operating system, and we can run a program on it, or maybe we can simply use a microcontroller. Okay, so I hope you heard about microcontrollers. So in that, you can burn a program, maybe an embedded C program or Arduino program in the microcontroller. So you can use any think module that you are interested in. According to the application, you can use. Okay, so this is the part that we are focusing on, the think part. Okay, because why? Because we are focusing on the robot programming aspect. Okay, and ROS is one of the framework to program robots. Okay, so after that, we are just seeing what are the main components that is presenting in the robot. Okay, so these are some of the actuators, popular actuators available in a robot. So you might see RC servos, stepper motors, DC gear motors. So these are very famous actuators. Then industrial servo motors. These are like using in the industrial robotic arms. Then there is a dynamic cells smart actuator, so which is using in the research robot. This is very expensive, like more than 20,000. There are different variants available. So it's very expensive. So these are belongs to the actuators. Now we are coming to the stepper, sensors. Sorry for that. We have uh, IR distance sensor, then ultrasonic sensors, then these are velodyne sensors, that is LiDAR. So you might have heard about the self-driving cars, right? So in that, we are mainly using these kind of sensors. Okay, and we have laser scanners, then depth sensors. You might heard about the Kinect Intel Real Sense camera. So that is the depth camera. So other than giving the RGB value, RGB images, it can give you the 3D point cloud, 3D 3D data of the environment. Okay, so these are belongings to the sensors. Now these are some of the computing units available. We have popular single board computers like Raspberry Pi, NVIDIA TX2, Odroid, Intel NUC. The Intel NUC is one of the famous mini PCs available. So it's a full-fledged computer, okay? And you maybe heard about the Raspberry Pi, right? So these are some of the modules, computing units that we can use in the robots. And of course, you can use the microcontrollers like Arduino, then Tivasi Launchpad or STM32 board. So these all belongs to the computing unit. Okay, so that's all about like a robot and main parts of the robots. Now we are switching into robot programming. Again, 2 slides. Uh, so robot programming. So from the name itself, you understand the concept, right? What is robot programming? It's simply programming the robots. That's all. So what is happening in robot programming? So basically, I mentioned that we have sensor, computers, and actuators, right? So where we are storing the program, we are storing program in the computers or microcontrollers. I mean, same thing in the thing section. So what we are basically doing is we are modeling the behavior of the robot, right? In the program, we are actually modeling the behavior of the program. Behavior of the robot, right? Uh, like when you write a program in robots, for example, in an obstacle avoidance robot, we are writing a program like if the sensor value is greater than 5, then do something. If the sensor value is lesser than 5, then do something. If it is not, then do other things. Right? So this is like a modeling of the behavior of the robot, right? And we are using some programming languages for that. Okay, it may be Arduino, it may be C++, Python, anything. Okay. So basically, robot programming involve the modeling the behavior of the robot. Okay, and what is the input to this model? It's the sensors, and what is the output? It's actuators. Okay, simply, I think you got the understanding of robot programming. So sensors as the input, actuators as the output, and we are simply modeling the robot behavior, right? And we are using like popular programming languages like C++, Python, C Sharp, Java, anything. You can use any. I mean, even MATLAB. You can use to model the behavior of the robot. Okay. And there are two approaches to program the robot. Again, a simple thing like if you're planning to implement a robot application for your robot, then what you can do is first you can think about like taking an existing program. That is very common, right? So if you have something to do, then we will directly go to Google, then type, hey, I just want to build an line follower robot. So you will get some code and you will download it and customize it, and it's ready to go, right? Sometimes, but most of the times it will not happen because there will be a lot of things to customize. Okay, so that's what the first approach is. Okay, so you can use an existing software frameworks or some set of programs or softwares to program your robots. Okay, so you are not uh, creating it from scratch, but instead of that, you are taking some existing software frameworks and customizing it and deploying it in your robot. Okay, so what are the advantages? It's quick prototyping, like it will not take much time. Okay, and I will say it is good for academic research because if you are doing PhD or something, your focus, the research focus will be on specific area, right? Very, very specific, and you don't need to bother about other stuff. Okay, so in that case, in order to set up a system, you can use some existing software for configuring other system, and you can specifically focus on your area. Okay, so that's why I mentioned it's for academic research. Otherwise, what happening is that if you're planning for building all the system from scratch, then you can simply focus on your you can't simply focus on your specific system. Okay, so this is for academic research, and you can also use some existing code for the product, but it's need a lot of fine tuning. Okay, so for example, if you work with, so I think, how many of you work with Arduino framework, Arduino boards? Just raise a hand. I hope some of you are already work with Arduino. Yeah, only two. I think I'm seeing 100 people here, and only keep on increasing. Yeah, it's 4 now. Okay, 5, 6. Okay, Yeah, I'm just checking how many of you are listening to my class. That's also, yeah. Yeah, it's keep on increasing. Yeah, good, good. Yeah, I think Arduino is very popular, right? Arduino, Raspberry Pi. Yeah, great. Yes, I'm seeing 14. Yeah, numbers keep on increasing. Yeah, I understood that this is, I mean, you guys know about this. Okay, great, great. Okay. Aware of robot operating system as of now. Okay, that's fine. That's fine. So these are the examples of some existing software framework. Okay. Just a second. So if you have any problem with the network or my voice, just let me know because I'm seeing some network issue sometime here. Okay. So just let me know if you have any issue with the network, guys. Okay. I'm also opening the WhatsApp if you have any issues. Okay. Yes. And the second approach is obviously writing from scratch. Okay. So for example, you are just using a programming language like C++, Python, and you are writing everything from scratch. Okay, so the issue is that it will take a lot of time. Okay, then but the good thing is that it is good in the long run. Like for example, if you are working on a product or something, then the good thing is that you will have all the control on the software because you have written it from scratch, right? So if there is any bugs, you can simply fix it. Okay, so that is the advantage of writing from scratch. So guys, just two methods: existing software framework or writing from scratch. Okay, and I just want to show you some of the existing software framework here. Like some of the examples are robot operating system that we are going to discuss, OpenCV, that is open source computer vision library. Again, the I think you have used the MATLAB, right? So in MATLAB, there is an computer vision toolbox, right? So basically that is giving ready-made functions to implement, to prototype our application, right? So OpenCV is a library which can be, I mean, used very similar to MATLAB computer vision toolbox. It is having inbuilt computer vision algorithm, so you can simply use it as APIs. Okay, and PCL is another library for working with 3D point cloud. Okay, again, open source. These are all open source software framework, so you can use it for free, and the software is open. Okay, and these are some of the free robotic simulators. Gazebo, which is coming along with ROS. Then OpenDrive, this is again a robot frame for motion planning. Okay, so these are some existing libraries. Okay, and if you want to do some simulation for robots, we have WebBoards and VRAP. Okay, so these are two new simulators. WebBoards is actually already there before 20 years. It's already there, but it was proprietary. But currently, it's free to download. Okay, and it's open source, so you can work with it. So these are some interesting simulators. Okay, and these are some of the popular programming languages that we are using to program robots: C++, Python, Java, C#, and MATLAB, of course. Okay, and I'm switching to another topic, and after that we can start with ROS. Okay, so guys, I think you have seen this kind of robots. Maybe your students maybe prototype this kind of robot. So how many of you see this kind of robots? I mean, simple line follower robots like this. How many of you? I think those who are already raised the hands, maybe just, I mean, yeah, if you have seen this kind of robot, then that's fine. Okay, so make sure after asking a question, if you raise the hand, and after that, maybe you can just click it again, so that option will go. Yeah, so I'm seeing a lot of hands here, so I'm assuming most of you have seen these kind of robots. Okay, um, so the thing is that in light follower robot or obstacle avoidance robots, we just need to use maybe a single microcontroller for its operation, right? Um, like that will do the job, right? So you don't need to put a full-fledged computer or a Raspberry Pi or those kind of boards in this robot, because we don't need that much of computation, right? We just need to put some microcontrollers to do this operation. Okay, so In this kind of application, in this kind of small robots, we don't need a full-fledged computer and we don't need an operating system. Okay, we just need a simple microcontroller, and you just need a simple program that is running on it. Okay, so single program, we just need a single program. Okay, so what about this kind of robots? This kind of just look at this robot. It is having two arms, there are several sensors, then there are grippers, there is a mobile base here. Then yeah, there are a lot of sensors, actuators. So it seems like complicated, right, compared to this, right? So what happening is that if you have a complex robot, okay, meaning if you have multiple actuators, multiple sensors, then if you want to do some complex application on this robot, then you might need lot of computers inside it to process the data from these sensors. Okay, so these sensors having cameras, lidar, so it's just very difficult to process this data because it will take a lot of CPU use, CPU, okay, and RAM. So guys, so if you are prototyping a complex robot, then it is obvious that you should have to go with a computer, full-fledged computer, maybe one or more, multiple computers. And in the computers, obviously, you have to install an operating system, right? And commonly we are using Ubuntu operating system, Linux, basically the Linux operating system to in most of the robots. And because Linux is free and open source, and we can heavily customize it for the hardware, so that's why we are using it. And on the top of this operating system, we can run multiple programs. Okay, it may not be single program. Okay, you may have to run multiple programs. For example, in order to handle a camera sensor, you may have to write maybe 5 or 10 programs that is running in parallel. Okay, so in a sense, if you have a complex robot, then you might have to run maybe 10, 20, or 30 or more than that programs in your computer. Okay, just imagine that. So for a complex robot, you may need this kind of stuff. I mean, a computer and an operating system on it. Okay. Okay, so that's what I'm trying to say, like why we need an operating system for robots. So for small robots, it's not required, but in complex robot, we need an operating system that is running on a computer, and we need to run multiple programs. Okay, okay, so that's it. And these are some of the operating system that we are using in robots, like Ubuntu, Debian. Okay, and also like in some time we are using Windows, but that is not common. And if you need the real-time operating system, there is QNX, VxWorks. Okay, so let's start with ROS. So in order to start with this framework, these are the prerequisites to start with ROS. Like you should know about Linux, mainly Ubuntu and Linux commands. Then you may need to know C++ or Python. Okay, so these are the mandatory requirement. Otherwise, it's very difficult to start with ROS. Okay, so if you are like working with Ubuntu, or if you know a little bit of C++ and Python, then you can start. Okay, so let's start with ROS. So I think very few people know about ROS, and that's what I understood. Okay, so we can start from the basics. Okay, so I would like to show you an examples. Okay, an example project. So guys, this project, I have done this project in 2010 as the part of my bachelor degree. Okay, and this robot is called a social robot. Okay, so the social robot means this robot can interact with people using voice, using gestures. Uh, yeah, you can see two eyes here. So this is like an animal head. Okay, there is like ears, then eyes, then there is a mouth here, and there is a neck here. So this much of portions. Okay, so in 2010, uh, I was basically implemented this project, and I just want to show you some of the capabilities and how I implemented it. So at this time I was not using rows. Okay, so this robot is like I'm seeing it's a complicated, I mean complex robot, because it is implementing this much of capabilities, and this can't be implemented in a simple microcontroller or something. Okay, so it is like it is having an ability to interact with people using some basic AI pattern matching technique, and it is having speech recognition, synthesis, face detection, so those kind of stuff. So I am assuming I need to run, I mean 10 or 15 programs in my computer. I was using two computers. You can see these are the brain of the robot. I'm using two laptops for processing it. Okay, and there are 12 RC servos, and I was using Python and C++ basically. Okay, so I was not using rows or any framework. I just implemented it from scratch, and you can see the software architecture. I mean, it's simple diagram how it is communicating. Okay, so I was like, I just mentioned the important programs that is running. The circle indicates that it's a program. Okay, so there are 5 programs that is mainly running. Okay, so each programs, like I think this program is running from one laptop and other programs are running from the second laptop. Okay, basically I implemented a server client architecture. Okay, so I think you may heard about the server clients. There is a server program and client program, and these program can interact with. Okay, so the circle shape is a program, and so basically each application is implemented on each program. Like the computer vision application is implemented in a single program, speech processing, artificial intelligence, Arduino communication. Okay, so these are implemented in a different programs. Okay, and the server program is like sending, receiving, like some data from speech processing is receiving by the server and it is sending to the Arduino serial, like that. Okay, so this is basically we are calling as a inter-process communication using, I mean, using sockets. Okay, so don't worry about the sockets, but just aware that if you want to work with a complex robot like this, okay, you may have to run multiple programs in your computer. Okay, in your computer means in the robot computer. Okay, and they have to communicate with each other. Okay, okay, so I think you are understanding the scenario. Okay, you're prototyping a complex robot and you have to run multiple programs that is doing separate tasks. Okay, and somehow these programs should able to communicate with each other. Okay, what is the use of this communication? It is exchanging the data, because the computer vision program can generate some output. Okay, the output of the computer vision program is some values. That value is communicated to the server program. Okay, so the server program will get that data and it can process it and send to some other programs. Okay, so what I'm trying to say is that there is inter-process communication happening. The word, I think, that is clear: inter-process communication between different programs in the computer. Okay, fine. So after that, so while working with this project, I had issues with these things. So uh, there is a problem with the inter-process communication, because I'm running these programs on different computers. Okay, so I just want to implement this inter-process communication capability in my robot. So I use the server client architecture. So if I have a framework to do this inter-process communication, then that will be quite easy for me. But in my first project, the issue that I faced was I have to create a method or a framework to communicate like this. Okay, so I faced issue with inter-process communication. Then there was issue with synchronization. Then like there is difficulty to use reuse the code, modularity, so those kind of stuff. Okay, so it was not very easy in simple sense, but the main problem that I faced was the inter-process communication, and I implemented it using Python server client architecture. I mean, simply the server client architecture. Okay, but if I have 10 or 20 or 100 programs in the robot, then this architecture is not viable. Okay, it's not very feasible, I will say. Okay, because I need to take care of all the nodes, all the programs, and it's very difficult to communicate. Okay, so this was the primary problem that I faced in my first project. Okay, then in 2014 I created a prototype. Okay, a food delivering robot, and I have used ROS. Okay, and you can see sensors like Intel, Microsoft Kinect. Then this is the computing unit called Intel NUC. Then there is some embedded boards here like microcontroller. So we can use microcontrollers with uh, PC. Those are contributing the computing unit. So in this, I have used ROS, and this is the communication diagram. Okay, so don't worry about the diagram, like the ellipse shape, or you can call it a circle. That is actually a program. Okay, so you can find a lot of programs here. There is gazebo, this one, EKF, then so these all are programs. Okay, and the line actually showing, the arrow actually showing the communication. Okay, so just like this. Okay, here I had 5 programs, but here I had multiple programs. Okay, it's not limited to like 5 or 10, but you can see how complex this is. Okay, so this is actually happening in my second robot. Okay, so what I did was, in order to accomplish this inter-process communication, because I have to write, I have to run several programs in my computer, robot computer, and I need to accomplish this communication. Okay, so in order to do this kind of complex inter-process communication, we can use the ROS. Okay, so that's where the application, the big applications coming. Like if you are programming your robots, and if you have several programs running in parallel, and if you want to communicate with these programs, then you can use ROS. Okay, and I will say ROS is a single, it's one framework. There are multiple frameworks to do this inter-process communication. Okay, but ROS is very popular, and you will get some robot related stuff along with ROS. Okay, I will get back to that. So I'm trying to show you the real importance of using ROS here. Okay, I think that is clear to you. Basically, you can implement this kind of complex inter-process communication applications using ROS. Okay, so we will see how we are implementing it, those kind of stuff later. But this is the main point here. Okay, this is a main point that I want to communicate with you in this talk. Okay, so we are using ROS in order to implement this kind of complex inter-process communication. Okay, yes. So I was trying to implement this autonomous navigation, then interacting with people, speech recognition, all these functionalities. So this is like a sample inter-process communication diagram. Okay. Yes, and each programs or node, we are calling it as node, um, is this ellipse. Okay, you can see each programs here. Okay, and each node is doing some computation, right? Each node is doing some computation, and it is receiving the data from other nodes. Okay, so we are basically calling this thing as a graph. Okay, can you imagine this as a graph? It's like a graph, right? So in graph, what is happening is that we have several nodes, and these nodes are interconnected, right? These nodes, like these are interconnected. Similar to that, imagine this as a circle. That is only the difference that I'm seeing. And these nodes are interconnected. Okay, so these uh, inter-process communication is actually forming a graph. Okay, and it's called Rose computational graph. This is a very important terminology, guys. So using Rose, you can create inter-process communication. Okay, you can write multiple programs using rows, and that programs can able to communicate with each other. Okay, and it can form a graph of computational nodes. Okay, graph of nodes. Okay, so that graph is called computational graph. Okay, I think that is clear to you. If you have any doubts, just raise your hand or just type your doubt in the type box. Okay, so this is a very important thing. So I assume that the computation graph terminology is clear to you. Okay, so if that is clear to you, then we are directly starting with what is rows. Okay, so just remember the things that I have mentioned. The use of I implement the server client, but it was very difficult for, if you are increasing the number of programs, then it will be very difficult to handle. But in rows, you can easily create complex communication graph, computation graph like this. Okay, right. So what is robot operating system? Simply, the robot operating system is a software library or software middleware. Okay, so from the name suggests, like, you may have some confusion, like the name suggests robot operating system. So first you may be thinking like, so is it a operating system like Ubuntu or something? So a lot of people ask me this doubt, but unfortunately, no, this is not an operating system, but this is having some features of real operating system. Okay, and it's called a meta operating system, or we are calling it simply a software library. Okay, the main agenda or main objective of this framework is to create is to create programs. Okay, using this framework we can create our own programs that can communicate with each other. Okay, so ROS is a free open source robotics software framework. Okay, and it's called a middleware, specifically a communication middleware. So it will help our programs, the user program, to able to communicate with each other in the OS operating system. Okay, and in order to run the ROS, we need a host operating system like Ubuntu, Windows, Mac or something. But Ubuntu is fully supported, and Windows is still, they're developing it. And the official website of ROS is ros.org. So I just want to show you the website here. Let me open my web browser. So just a second, guys. Let me take it. So you can also take the ros.org. Okay, so this is the official website of ROS. Okay, you can have it. You can have a check. Maybe I can send the link in the chat box. So you can find some distributions of ROS. Don't worry about that. There is an installation procedure here. Okay, so we will coming to this thing. Okay, I just shown this. Okay, just for your understanding. Okay. Okay, so let's see. So I am assuming these are clear to you. Okay, these fundamental stuff. So let's see how to install this. Okay, so that is the second thing. So you have seen ROS is a software framework and it's need a real operating system to run. Okay, so how to install ROS in your system? So if you have Ubuntu, that is the preferred OS for working with ROS. So you can find this ros.org install link, and you can find these things. Okay, so there are two different versions. Main versions of ROS, that is ROS 1 and ROS 2. Okay, so in ROS 1, it's actually started in 2008, I guess. Yeah, 8, and it is maintaining up to 2025. Okay, so this is the last version of ROS 1, and this is ROS 2 version, current version. So if you want to install the ROS 1, just install it. Okay, I am actually showing it with ROS 1 now. Okay, so I'm using the latest version of ROS 1. It's called ROS Noitic, and this is the installation procedure. Okay, so you don't need to worry about the installation procedure. Like, these are very simple step. It's only like if you have a Ubuntu operating system, okay. So I'm using a tool called VMware so that you can install Ubuntu on this application, okay. So if you work with Ubuntu or Linux, you may be aware of Linux terminal, okay. So what you have to do is that in order to install, you just have to copy these commands, okay, and paste it here, okay. So that is the simplest method that you can do. Like just copy paste this command, this one, and this one, and this one, okay. And one more thing, if you can do this, it will be finished, okay. Just have a I mean just have a look onto the text that is mentioned on the top, so you will get an idea what is going on in each command, okay. So I also put a simple installation instruction in my blog, so I can share that also. So that is actually a single line installation. Just a second. So I'm sharing that link also. So in order to install ROS Noitic, what you have to do is, I have put a video also. So just copy this line, okay, for installation and paste it here, okay. So that will do the same job. I mean, this job in a script, okay. So this is the method to install the ROS 1, okay. And ROS 2 is still on development. Some of the main things are still on development, but you can also install ROS 2 on like Ubuntu Linux, Mac OS, and Windows 10, okay. So the ROS Noitic can be only installed on Ubuntu 20.04, okay. Okay, so this is about the installation, okay. It's very simple. It's a straightforward way to do the installation. And in order to install um, ROS, you may need Ubuntu, okay. Yes, so I'm using ROS Noitic along with Ubuntu 20.04, okay. Yes, okay. So that is the installation, guys. So let me go back to the testing. So I hope you can able to see the screen. So after installing, you can use a command to verify the installation is correct. So you can use a ROS core command, okay, which will start a ROS master program, which will basically verify the installation is correct, okay. So if you're getting like this, it means that the installation is proper, okay. Yes. Okay, so that's it about the installation, guys. Okay, now we are coming to the important point. So we have seen what is ROS. It's like an open source framework to program robots, and it's also called a communication middleware, and we need Ubuntu for installing this. We have seen the installation instruction. Now, what is mainly ROS? That's an important, I mean, what is inside it? Okay, so that is what we are going to discuss now. Okay, so let me try to take the full screen, but I'm not. Just a second. Do I have to? Okay, fine. Okay, fine. Anyway, so this is called the ROS equation. Okay, ROS equation. And what does that mean? Okay, the ROS equation simply says what are the important components of ROS. Okay, so that is actually a ROS equation. So let me just I mean make it as a full screen, guys. I'm not able to do it. Just a second. Okay. Okay. Anyway, like I'm not able to access the pen. Anyway, that's fine. So what are the important things inside this ROS? So what the first thing is the plumbing. Okay. So it's not the plumbing in our homes. So plumbing is what I already mentioned. that is the inter-process communication. Okay, so in ROS, it is actually providing us an inter-process communication middleware. It's also called the communication middleware. And using this middleware, your program can able to communicate with each other. Okay, and I also afraid about this middleware term. So if you don't heard about middleware, the middleware is actually again a software that is acting between the operating system and the user program. Okay, so this software is called the middleware. And what is the purpose of a middleware? The middleware is actually like doing some operations. Okay, that is actually simplifying our I mean our simply our life, because if you want to do a inter-process communication, then using a communication middleware you can easily do this. Okay, so that is the important part of ROS. Okay, so along with that, ROS is having some interesting tools. Okay, so in order to visualize and debug this graph that we have created, the computational graph that we have created using this uh, middleware, we can use tools to visualize these data that is passing across different programs. Okay, we have seen the computational graph, right? Meaning there are different programs and sending data each other. I mean they are sending data, so those data can be visualized, debug using these tools. Okay, and the third thing is the important one, that using this inter-process communication capability, ROS is having some robotics capabilities. Okay, meaning if you want to create an autonomous mobile robot, imagine if you want to create an autonomous robot. Okay, then ROS is providing some inbuilt packages, okay, or inbuilt software in order to create an autonomous mobile robot. So you don't need to code at all. You don't need to write a single line of code. It's already there, and you can just download it and customize. Okay, also if you want to work with a robotic arm, okay, then you don't need to write any code. You can just download this package and customize it. Okay, so it's very easy to very easy to customize. Like if you want to prototype a robotic arm, just download the package from ROS and customize it, and it's ready to go. You can work with the robotic arm. And the fourth thing is that there are a lot of developers that is working in ROS framework. Also, you will get a lot of support if you have facing any issues or something, you will get a lot of support. Okay, so that is the ecosystem. Okay, so I assume that you got an understanding about this plumbing, that is inter-process communication. I already discussed about it. Then in order to inspect this inter-process communication or this computational graph that we have created, we have the tools. Okay, so what tools does is that it helps to monitor all the data that is sending across the different programs. Okay, so basically you can visualize the sensor data, then a robot model. So these things can be visualized using these tools. Okay, okay, so this is the main part. The ROS equation is the main part in our talk. Okay, I hope that is clear to you. So this is the same thing that I explained, and I just want to I mean show an example of inter-process communication. So simply we have computer here, then on the top we have the operating system, and we have ROS. Okay, so using ROS functions, okay, ROS giving us some functionalities, okay, like we will call it as APIs. Okay, so using that, one program can communicate with second program can communicate with one. Again, like I'm just showing an example. Okay, I think you guys understood. Like it's like maybe program 1 can communicate with program 3, then program 3 with program 2. In any ways, in different ways it can communicate. Even program 1 can communicate with program 3 in different ways. Okay, so in each communication it can send different data. Okay, so these are different ways in which a program can communicate with another program, okay, using ROS. Okay, and this is a practical example, again a simple demo. Like here we have a program called camera driver. Okay, so that program is fetching images from camera, real camera. Okay, and that image is sending to a second program, that is a face detection program. Okay, so the face detection program will receive the images from this program and do the face detection. Okay, and send the sender of the face or centroid of the face to another program called send centroid to Arduino. Okay, so this program, what that does is that it will receive the centroid from this face detection program and send this value to Arduino board. Okay, so this is how the inter-process communication happening. I just demonstrated an example. Okay, okay. So let me know if you have any question till now. Mainly, I'm emphasizing on that inter-process communication and the computation graph. So just put your doubt on chat box, okay, to make sure it's clear to you, because these till now, till this slide, you should have an understanding about this inter-process communication that I'm talking about. If you have any doubts, let me know. Okay, so so if you don't have any doubt, I am assuming that it's all clear to you, then then only I can proceed to the next slide. So I'm giving you 1 minute. Okay, so if you have any doubts, let me know. We can take one or two questions now, and after that maybe at the end we can handle many questions. Yes, so let me know if you have any specific questions. Okay, so the first question is from Manoj. He's saying, he's asking, do we have Windows version of ROS? So the thing is that if you're working with ROS 1, there is um, Windows version for ROS 1, and ROS 2, there is also Windows version. But for the ROS 1, the Windows version is not, I mean, very matured. It's still on development, I will say. Okay, but you can use it for sure. You can use the ROS Nautic in Windows. Okay, you can use. Then the next question from Tejas, he's saying, he's asking, is it necessary to install ROS only on Linux operating system? So yeah, that's what I explained. The complete capability, complete features are available with Ubuntu operating system. Okay, full support is for Ubuntu. Then you can work with Mac and also Windows, but I will say most of the features are not available. Okay, but you can still use the basic functionalities. Okay, so Tejas is asking, oh, we can use Windows 10 also. Yes, you can use Windows 10. You can use Windows 10 and with ROS Nautic. That is, you can use that. Okay. Yes. So okay. So one more question I'm taking. Can we download ROS in mobile? Okay, that's an interesting question. So as I mentioned, currently ROS is can be only installed on operating system like Ubuntu, Windows, Mac. Okay, and if you want to work with Android or iOS, we have the mobile clients. Okay, client means you can implement a program in your computer. In your computer, and also you can implement a program in your mobile phone. Okay, there is a thing called ROS Java that will help you to create Android application using ROS, and that application can communicate to ROS. The things running on the PC. Okay, so there is an option to connect the mobile phones to the ROS environment. So that thing I can discuss. I can discuss that. So when we discuss the concept, you will understand. Okay. Okay. So I'm taking that much of question now. So I am assuming this is clear. And if you have doubts, just post and I will answer at the end. Okay. So this is the other things uh, like so where is ROS? Where is the position of ROS in the operating system? Here we have the robots. On the bottom you have the real robot, okay? And on robot we can put a computer, and inside the computer we have Ubuntu, and on Ubuntu we can install ROS, and using ROS functionality we can create ROS application or robot application. So this is how it's happening, okay? If you create an application on ROS, that means you are like writing your application using ROS APIs. Okay, so this is more, I will say, zoomed diagram. Okay, so the ROS is having like the ROS layer here. It is having two layers. It is having a communication middleware, okay, and some libraries. And this is the red box is the important one for us. It is providing client libraries, meaning for example, if you want to program your robot using C++, okay, then you can use ROS CPP client libraries, okay, that is providing by ROS. And if you want to program using Python, then we have ROS Py, okay. So you can use ROS Py modules, and you can implement this ROS communication using these libraries. Okay, so this is what we are using it for implementing our application. So the one question was how to work with a mobile phone. So we have ROS Java also. Okay, and also for iOS there is some other client. So you can use these different client libraries like ROS CPP, ROS Py, ROS C Sharp, ROS Go, ROS Java. So you can use those libraries, ROS libraries, for specific programming language. Okay, it's called the client libraries, and you can create application at the top of that. Okay, so we are creating this robot application using these client libraries. Clear? Okay. So now the important thing I already mentioned about the computational graph. Okay, so simply the computational graph is having a list of ROS process or ROS programs. We are calling this a ROS node. Okay, ROS node like this. The circular or ellipse is a program, and it is all running on your operating system. Okay, and these programs are communicating with each other. Okay, so this is what we call the ROS computation graph. Okay, so if you are using ROS client libraries to program your application, then you can able to do this kind of communication and can form a computation graph. Okay, important stuff, don't forget this. Okay, fine. So now we just want to discuss three concepts again, very simple. So uh, so you have seen this graph, right? Okay, so there are some terminologies associated with this graph. Okay, so these programs, okay, the ellipse structure is called the ROS node. Okay, so in the graph, you know, we have nodes, right? So similar running program is called the process, and we are calling that process as a ROS node. Okay, so here program 2 is a ROS node, program 5 is a ROS node, program 6 is a ROS node, like that. Okay, so that is ROS node. Then next terminology is the program 2 is communicating with program 5, right? Okay, and in exchanging a data. Okay, so the type of data that is program 2 is sending to program 5 is called ROS message. The type, okay, that is specific. The type, I mean the data type. It may be integer, it may be string, it may be like float. Okay, so it may be a custom data type. Okay, so that type is called the ROS messages. Okay, so that is the type of data it is sending. It's called the ROS messages. Then this arrow, right? So this is called a data bus. I mean, the program 2 is sending program 5. Some data is sending, right? The type of data is called ROS message, and program 2 and program 5 are ROS nodes. Okay, and program 2 is sending to program 5 using a data bus. Okay, there is a bus created, data bus is created between these two nodes, and this data bus is called ROS topic. Okay, so ROS topic is called the named data bus. Okay, so we can create a name. for this database, similar to our national highways. Just imagine our national highways. We have NH17, NH47 in Kerala. So 17. These are named highways, right? National highways. So similar to that, we have the named database. For example, if I'm naming a database as Lendin, and I can assign a rows message that is flowing through that database. Okay, I can create a database between program 2 and program 5, and I can send integer data through it. Only one type of data can be sent through one topic. Okay, so in order to send multiple topic, you have to create another database. Okay, so that is called the rows topic, and that is shown here. So we have two nodes here. This is one node and this is one node, and topic is the database. Okay, so here I'm showing an example called the topic name is called chatter. Okay, and the message type is string. Okay, it's a string data, a string topic, and the message data is called, I mean, the data that is flowing through this topic is hello world. Okay, so node A is there, node B is there, and these much of concept is clear. Is it clear to you? The rows topic, rows message, and the data that is flowing through it. Okay, so this is very important. Okay, the very basic concept, and you can send. I mean, here it is node A, and node A can simply send the data, and it can consume by different nodes. Okay, okay, so rows topic, rows message, and the node that is sending the data is called publisher, and node that is consuming or I mean receiving the data is called subscriber. Okay, so we have the publisher node and subscriber node. Okay, so publisher is sending the data and it can be consumed by several subscribers. Okay, and similar to that, I mean, a list of nodes can send the same rows topic. Okay, and it can be consumed by several subscribers. So this is the important concept of rows, that is rows concept. We have some other concept left, but that may be confusing to you. Like this is like the node A continuously sending the data, and we have a service request response system, like it is called a row service. So if I just want to give a request like, hey server, what is 2 plus 2? Then these are two programs, by the way. Okay, and the client program can give a request to server, and after processing it, server can reply back. Okay, so there is another kind of communication in rows, that is row service. The first is rows topic, then row service, then rows action is there. So in rows action is the upgraded form of row service, like it is sending a goal to server, then the server can respond to feedback and also the results. Okay, okay, and finally, I think this is a important thing, how rows nodes are establishing connections. Okay, so this is how the communication between rows nodes are establishing. Okay, connection. So we have seen the computational graph and all. So this is how two programs are getting connected. Okay, so in India, yeah, I mean, commonly we are going for arranged marriages, right? So in arranged marriage, we may have a broker, right? We have a broker, and maybe it may be a matrimony site. So what is happening is that boy and girl is there, they have different I mean requirements basically, and they have their own profile, right? So what is happening is that in arranged marriage, we are like sharing these information in matrimony or to a broker. Okay, then broker is doing some matching, and if there is a match, then broker will share the data. I mean, hey, there is a girl like this, there is a boy like this, and if both the parties, that is boy and girl, interested, the broker will share the contact details. Okay, then they will start communicating with each other. Okay, the same thing is happening in rows. Okay, so in rows there is a broker program. It's called the master. Okay, so In order to establish connection between two programs, two or many programs, okay, in rows, we have a master program. Okay, so it's similar to the broker. And if a boy and girl want to marry, then they will submit the details to master program. Then after that, master will do a cross check, and if there is any match between these, like uh, we are taking a lot of matches, right? Caste, religion, then ec- I mean status, lot of things, right? Whatever, like the broker is doing this match, and if there is a match, it is sharing with these parties. Okay, and if it is good, they will start communicating with each other. The same thing is happening here, guys. So we have the master. So initially we have to call a broker. Okay, so here instead of marrying a boy and girl, we are two programs are getting married. So we are starting the rows master. So there is a command called rows core. Okay, so if you install rows, you will get this command. So when you install this command, I mean uh, when you start this command, I can show you this example in parallel. So the first command is rows core. So I'm starting the broker. Okay, fine. So the broker is running. Then what happened? Just see. So now broker is ready. Then here is the boy program, that is talker. Okay, yeah. So talker is saying, hey master, hey or hey broker, I have PhD from IIT, or I have this much of money, so I need a pretty, I mean, good girl with a lot of wealth or something. So he's sending his resume and I mean all his requirements to the master. Okay, so I'm starting the boy program. So there is an example program that is supplying by Rose. So here is the talker. Okay, so talker is I mean it's actually send the details to the master. Okay, then again, then a girl approached to the same broker, and she said to master, hey, I need a very, I mean, good looking guy with a lot of money or something like that. So girl approached and shared the details. Now what happened? There is a match. Okay, then the master is exchanging data, and then contact details, contact information received, the mobile number got received, then they start chatting. So broker is out, no need of broker. Okay, so this is how it is happening, guys. Okay, so currently you can see I'm starting the girl program, that is listener. Okay, there is a terminology difference, because talker should be girls and listener should be boys, because boys always listen and girls always talk, I guess. So if I'm giving listener, you can see these programs are communicating with each other. Okay, so the same data, it is sending hello world with a number. Okay, so that data is receiving here. Okay, so this is what happening, basically what is happening in rows. Okay, and if you just check the computational graph, you can view the computational graph in rows. Okay, so I can show you the computational graph. This is a computational graph. Very simple, right? There are two programs, and talker is communicating with the listener, and this is the topic. Okay, so that's how it is showing. So talker is communicating with the listener over a topic called chatter. Clear? And chatter type is, the type of data it is flowing through is string. Okay, clear? Okay, yes. So that said, okay, so that is what happening in the communication. Okay, so this is the example. Okay, right? Then I can show you another demo using this same communication idea. I can show you a much better example. So we have a program called TurtleSim. I'm not sure how many of you heard about logo programming. So I think like in education startups like there are a lot of education startups, right? So those guys are using this kind of simulator called turtle sim. Okay, basically moving the turtle is the objective. Okay, so this is the turtle ROS program. It's like a simulator, and in order to move the robot, I can start another program. So let me start that program. Yes. Okay. So now I can able to move this turtle. Okay. So what is happening, guys? There are two programs. That is this program. This GUI is a program, and I also started another program called Teleop. Okay. And what is happening? What is happening? Let's have a look. This is what happening. Teleop Turtle, that is a program here, is sending a topic or sending some data to TurtleSim over a topic called command velocity. Okay, and so command velocity is it's a velocity to move the turtle. Okay, so we can view this topic or the value over this topic using this command. You can find it is sending the linear velocity. Okay, so if I'm stopping the robot, then the velocity is assumed to be 0. But if I mean moving the robot, you can find like the values are changing. Okay, so this is what happening. Like two programs are communicating with each other. Okay, and you can see this data. Okay, yes. So that's it about the communication. Okay, so now I'm quickly go through the other concept. So this is the fundamental concept that I want to convey to you guys. Other things I can show you as demos. So these much of things we have covered. Now we can quickly go through the other concept. Okay, there are three concepts left. Okay, so the first part of the equation was Rose plumbing, and now we have the tools, right? The second part is the tools. So Rose is actually giving some 3D and 2D tools. Okay, I can show you that, then only you can understand. So there are some 3D tools like this called RVs. Okay, so this is one tool that is provided by Rose. Okay, so in this we can display the 3D data like point cloud. We can display the robot model, all kind of stuff. Okay, so I can show you this tool again during the demos. Okay, and there is another tool called RQT. I think that you have already seen. So this is like a 2D tool. Okay, you can visualize a lot of things by loading the plugins. Okay, so these are the tools that is Rose providing. I mean, mainly important tools. Okay, so the tools can be used for visualization as well as debugging. Okay, so these are the GUI tools, and also it is providing the command line tools like this. Okay, so these are the command line tools in order to check what are the data sending between two nodes, what is the I mean, these tools are for introspecting the Rose computational graph. Okay, right. So this is how I'm saying an example how to apply Rose in a simple robot. Okay, so we have a mobile robot like this, and this is a circuit. Like you may be familiar with this, like we may have an Arduino robot, Arduino controller, and there is a motor bridge. So we have left motor, right motor, and we have encoders, and there is a Bluetooth module. Okay, so I just want to show you how to interface a robot to Rose. So this was one of the prototype, and this is how it's working. Like these blocks are programs that is running on PC. Okay, so this is actual robot, and this communication happening over Bluetooth, and these are the different programs that is running on PC, and these are the communication diagram. Okay, so I just want to show you how to implement Rose in a real robot. Okay, we have to run multiple programs, and these program will sending some information about the robot, like this command velocity. Then command velocity is converting into motor speed. Then encoder values are converting into transformation. So these things are happening using ROS. Okay, using the ROS inter-process communication. Okay. So that is the ROS tools with examples. And now I just want to show you the capabilities using a demo. Okay, so I mentioned that if you want to build a autonomous navigation robot, that is quite possible using ROS. Okay, ROS is giving packages, so we can simply customize it and we can create an autonomous mobile robot. Also, you can simply create a robotic arm like this. So this is the navigation and this is the manipulation. So using navigation stack, we can create a map and we can go autonomously like this and ROS move it. I can show you a video of the navigation stack in ROS. So here is a map and I'm giving a goal position. So the robot will path plan and go to that position. Okay. Yes. So in the manipulation, let me, oh, sorry for the sound. So this is like a real world example. The robot is picking. So you can see in the monitor, you can see the RVs. And this is ROS manipulation. Okay. And this can be easily done using ROS packages. Okay, so these are the inbuilt capabilities of ROS. Okay, so now the perception, there is another capability of perception that is like this. It is the data taken from an autonomous self-driving car. So using the perception packages, you can create map like this. Okay, you can handle 3D sensors. Okay, so it is actually creating a 3D map of the environment. Okay, this is a 3D map, guys. Okay, so these are all possible using ROS. Okay, and this is ecosystem. Basically, I mentioned that a lot of developers are working in ROS, and India is like 5th. This is an old metric, but India is like in 5th and 6th position in ROS users. Okay, and the full support of ROS is for Ubuntu, and it is also working with Mac and Windows. Okay, and just a history for 5 minutes, like who created ROS and what are the different distributions of ROS. So ROS actually started in Stanford, not that name, like ROS name. It's called Switchyard. And after that, there is a company called Willow Garage. So this is a guy who started this project, Morgan Quigley. And after that, this Willow Garage, a research company called Willow Garage, taken this project from Stanford and they did the major development and they given the name called ROS. Okay, so now Willow Garage is actually stop its operation. And these are the contribution of Willow Garage. There is a robot like PR2, then Turtleboard. These are the robots. And currently, ROS is maintaining by Open Robotics Foundation from 2013. Okay, so this is the main team. Brian Jerk is the CEO. And so the main importance of using ROS is like I mentioned that like we can reuse the packages. Like if you build a software for your robot, that package can be reused maybe by some other person. Okay, and it's providing the modularity, like it's like a Lego block. Okay, and it's free and open source, and we can easily work with the inter-process communication. Okay, and great community support. Okay. Okay, so and these are some of the distribution. Distribution means you have the Windows 7, Windows 10, Windows 8, like that, right? And in Ubuntu, we have Ubuntu 16.04, 20.04, and also if you take Linux, we have Ubuntu, Debian, then Fedora, those kind of stuff, right? So similarly, we have ROS distribution, and these are some of the ROS distribution. From 2010, I have mentioned Rose Diamond Black. I started working from Sea Turtle Diamond Black at that time. Okay, electric, furate, hydro. So this letter is actually changing. Rose, indigo, jade, kinetic, luna, melodic. So currently it's noitic. Okay, and the latest version of Rose 2 is Rose 2 Foxy. So Rose 2 is like it is having some improved capabilities compared to Rose 1. Okay, it can be used for products. Okay, so currently it's like developing. A lot of packages are still porting to Rose 2. Okay, and these are some of the robots that is working on ROS. Turtle board, PR2, then Baxter. This is, you will get a lot of robots. Like if you just Google about it, there is a section for robots, Rose robots in their website. Okay, I'm simply going through this. Okay, so these are some video demos. I'm just avoiding it. I will show the real demos. So these are some of the sensors supported. You can easily work with these sensors using Rose. Okay. And these are some of the IO boards supported. So you can simply connect this board to the computer and you can run some programs in your computer, and the data from these programs will be accessed in the ROS environment in the computation graph. And these are some of the libraries that is using in ROS. We have OpenCV, PCL, Gazebo. It's a simulator. So these libraries are supported in ROS. Okay, so now we have two topics left. Who all are using ROS and what is the importance of using ROS? Okay, so major companies like Intel, then Fetch Robotics. I mean, those are key players in robotics domain. And also you maybe heard about BMW, then Nvidia. So this is not the complete list. There are a lot of companies, even like TCS, Wipro, all people are using ROS, okay, in the research, okay. So there are a lot of job opportunities associated with ROS in India as well as US. I will say the opportunities are higher in US, okay, compared to India, but in India it's actually booming. Okay, so if you just check about robotic software engineer, then robotics engineer or ROS developer, you will get a lot of requirement like this. Okay, so what is the use of learning ROS? Again, the job opportunities are the research opportunities are the. For example, I could work with Robotics Institute CMU, which is one of the famous uh, universities for robotics because of ROS. Okay, so they actually took me as a research assistant because of my ROS capabilities. Okay, and if I'm talking about the soft opportunity of robotic software, so when the computers came, the main possibility of computers are explored using the operating system, right? When the Bill Gates started the Microsoft, he introduced Windows 10. I mean, sorry, Windows 95. Sorry for that. And there is Linux, GNU/Linux operating system. So these are exploring the opportunities of computer. Okay. So regarding ROS is actually regarding robot programming, ROS actually exploring the possibilities of a robot hardware. Okay, so there are a lot of opportunities and a lot of scope regarding robot programming. Okay, so ROS is one tool in order to explore this. Okay, yes. So there is a ROS conference called ROSCon that is happening every year. So last year I could attend ROSCon and I could um, release my last book, ROS Robotics Project Second Edition, and this is the CEO of Open Robotics. Okay. Yes. So now I just want to show you two demos. One is for navigation and one is for manipulation. Okay. So in the meantime, you can ask question. Okay. So let me know if you have questions, and I will be answering that question along with the demo. Okay. After that, we can wind up. Okay. So let me know if you have any questions. So I will be start showing the demo. Okay. Okay, so there are one old question. Let me check that. So RPI can be used with Raspbian. Yeah, that was one question from Manoj. So RPI can be used with is it okay, Raspbian? Yeah. So in Raspberry Pi, we have an operating system called Raspbian, and you can install ROS in Raspbian, as well as you can install Ubuntu on ROS. I mean Raspberry Pi, and you can install ROS on Raspberry Pi. Okay. Yes. So I'm just planning to start with the demos. Okay. So maybe I can start with the turtle board. Uh, Let me check. So turtle board is a simple robot for education. Okay. Let me check. I'm going to show you a simple.
Sir, not audible, sir. Sir, you're not audible, sir.
Hello.
Yes, sir.
Okay. Okay. So unfortunately, there is some issue with the network connection.
Okay,
Sorry
sir.
for that. Yes. Let me show you the demo. Let me share the screen. Um, yes. Can you able to see the screen, guys? I'm sharing the screen. Can you able to see?
Yes, sir.
Okay. Okay. Great. Okay. So I'm showing the navigation of robot. So basically, we have a map. Okay. And I'm giving a goal position here. So you can see it is path planning, and the robot is moving to that goal location. Okay. So this is actually working using rows. Okay. We can give a goal position like this, and robot will go like this. Interesting, right? These things you can do without any code. I mean, any without any new code. Okay, just customizing is fine. Okay, so these are possible using that. Okay, now I just want to show you a manipulation example. Okay, and manipulation means like pick and place, but I'm not showing the pick and place. I just want to show you I mean how we can do the motion planning, those kind of stuff. Let me start. Okay, so there is a robot called Franga robotic arm. So let me show you that. So here is the robot, okay, in simulation, okay. And this is the setup for motion planning, meaning simply giving, you can give an end effector position like this. Okay. So the robot will move to that position. Okay. Simple, very simple. I think you maybe heard about this inverse kinematic stuff or something like that. So that is actually working here. Okay. So let me do that. Maybe I can just minimize it. Okay. Okay, you can find the things that we are motion planning here, okay, that is executing on the simulator robot. And if you have the real robot, that will be executing on the real robot, okay. And these capabilities are using rows. It's called the rows move it, and you can simply perform these things in rows without writing any code, okay. Okay, so these are the two demos that I want to show to you, okay. Navigation and manipulation. Now I am coming to your questions, okay. So let me take your questions. Okay. Yes. So okay, I'm starting from Kausik. So thank you, sir, for your wonderful demonstration. Will you please explain what are the sensors and actuators required for a humanoid robot, a rock climbing robot, and this Raspberry Pi can be used for its operation? So that's actually a big question, Kausik. So for a humanoid robot, I think the purpose is rock climbing, right? I mean, yeah, for a humanoid robot, humanoid rock climbing robot, right? So actuators, obviously, in a humanoid robot, we have like intelligent servos like dynamic cell. So if you search for robot is dynamic cell, these actuators are very good for the humanoid robot, but it's a bit costly. And you can also see the humanoid robot from Robotics, that is a company manufacturing this servo, okay. So you can think about these actuators, okay. That is pretty good. And regarding the sensors, so I'm not very clear about the rock climbing part, so how it is climbing. So I think you should have some force feedback sensor if it is climbing through, using legs and hand, maybe for getting some feedback, how much grip that it got in the surface, something like that. You may need some force feedback sensors. Okay, and you can use Raspberry Pi for sure. You can attach this Raspberry Pi on the back of the humanoid robot. That is possible. But I have a doubt regarding these sensors. The problem is I don't know the operation of this robot. So maybe a force feedback sensor will help to get the feedback that is robot is touching, and accordingly you can increase the torque. Like if the force is not enough, then you can increase the force required to grip the surface or something like that. Okay, so from S. Kandekar, a very much informative session for beginners. Thank you for that. Then Lale, okay, not audible. So there was a problem with the internet connection. Yes. Then yeah, I know that there is a problem with the voice because I'm currently connected through my mobile phone, so there will be an issue. Then from Anbu, that is the last question I'm taking. So how about using ROS in an embedded system, standalone system with hardware platform? Okay, so you can connect ROS with Arduino and all. Okay, so it's like ROS not working as an independent or it's not working as a independent entity, but instead of that, it is working. It's acting as a ROS node. Okay, so there is an interface with ROS and Arduino. Okay, and also some other microcontroller platform. Okay, and there is another thing called micro ROS. Okay, micro ROS. So which is for ROS 2. So that is kind of independent for microcontrollers. Okay. Yes. So that's it, guys. I have another meeting coming up. So sorry for that. Otherwise, I will spend 10 more minutes, but I have to go. So thanks for inviting me. I think you got some understanding about ROS, the basic stuff. Okay. So if you need any other further help, you can just go to my company website and just give a contact request or something in the company website. You will have a I think a contact form or something. Yeah, you can send a message to me. Okay, I'm also running a course called ROS Developer ROS developer, just a second. I think ROS developer by LinkedIn. If you just search about it, I think you will get my course. So that is a big course actually. Like, yeah, it's a paid one, not free. So it's called ROS Developer Learning Path. Okay. Yeah, maybe I can send the link if you are interested. Okay. So thanks for inviting me, and I got to go. Okay. So thanks for the organizers. Okay. Yes. Thanks again. Yeah. Bye. Bye, everyone. So I'm just signing out. Okay. Bye.
Thank you. Thank you for the nice session, sir.
Thanks for inviting me. Bye.
So dear participants, now you can go to the YouTube link every time and have a look at all the details of the lectures whenever required. And next session will start at 1:30 now, okay, after lunch. So let me give you the idea that it will be demo lecture by Mr. Ajit Mutalik on URDF and XARCO, and it will be also on creating a basic two-wheel differential drive robot in ROS. Okay, so we'll be meeting at sharp 1:30 now. Okay, so thank you all. Yes, feedback link, you have to directly go to the ATAL portal website, and there you will have to give the feedback at the last of all the sessions. Okay.